welcome back to today's story of Outliers. Let's dive into something that might sound a bit unusual at first: rice paddies and math tests. We're going to explore a surprising connection between two worlds that seem completely unrelated. And in the end, it may change how you think about what success really means. You might be wondering what rice paddies have to do with math scores. The connection isn't obvious at first, but it reveals something important about where success comes from. And the surprising part is that it has much less to do with natural talent than most people assume. Let's start with something you've probably seen before. On international math tests, students from East Asian countries have consistently and often, by a wide margin, outperformed students from Western countries. This pattern has shown up across multiple studies and over many years, making it too consistent to ignore. The real question is not just that the difference exists, but why it exists in the first place. And we're not talking about a small gap. The difference is huge. Students from places like Singapore, South Korea, and Japan often rank in the top few percent worldwide on math tests. Meanwhile, many Western countries tend to sit much lower in the global rankings. This isn't a slight difference, it's a completely different level of performance. The simplest explanation people often reach for is natural talent, some kind of built-in advantage in math ability, but the evidence tells a different story. It points much less to genetics and much more to something deeper and less obvious: culture. So, where do we start looking for answers? One important clue is right in front of us in language itself, especially the way numbers are spoken. It turns out that how a language is structured can give people an unexpected advantage when learning math. To understand this, you need to know a small trick about how your brain works. We all have a short-term memory loop that lasts only about 2 seconds. If you can say something within that time, you're much more likely to remember it. Try it. 4, 8, 5, 3, 9, 7, 6. If you're an English speaker, you might only have about a 50/50 chance of remembering all of it correctly. Here's why this matters. In Chinese, number words are very short, so they can be spoken quickly and fit more easily into our short-term memory, which only lasts about 2 seconds. But the bigger advantage is the structure of the system itself. In English, numbers like 11 and 12 don't clearly show a pattern and have to be memorized, while in Chinese, the system is very logical and transparent. 11 is 10 and 1, 12 is 10 and 2, and 21 is 2 tens and 1, making it much easier to understand how numbers work. You can see the impact very early on. A 4-year-old in China can often count up to 40, while an American child the same age may struggle to get past 15. The number system also makes basic math feel more intuitive. For example, a fraction like 3/5 inches Chinese is expressed as out of 5 parts, take 3, which makes the idea much clearer from the start. But that advantage in language is just the beginning. The real story goes deeper. To understand it fully, we have to leave the classroom and look at life in the real world, especially the long history of growing rice, which shaped powerful cultural habits over time. Growing rice is very different from growing crops like wheat. You can't just scatter seeds and wait. Farmers have to build flooded fields, carve terraces into hills, and carefully control water through irrigation systems. They also have to weed and manage the crops by hand with a lot of precision. It's not simple work. It's a complex year-round process that takes skill and constant attention. And the workload is staggering. Think about it. A peasant in 18th century Europe might work around 1,200 hours a year and basically rest through the winter. A rice farmer in China, by comparison, could work close to 3,000 hours a year with no real off-season at all. And this mindset becomes deeply embedded in the culture. As an old proverb puts it, while a farmer in France might rest or take time off, a rice farmer cannot afford to stop working because if you stop, you don't survive. It reflects a very different relationship with effort. Work isn't seasonal or optional, it's constant, necessary, and tied directly to survival. But here's the key idea: you really have to understand this part. This wasn't just exhausting, backbreaking labor, it was meaningful work. Unlike a serf in Europe working for a lord, a rice farmer was working for their own family. The job was complex, and there was a clear link between effort and reward. The harder and smarter you worked on your rice field, the more food you had. That changes everything. Okay, so how does something like rice farming connect to a kid sitting in a math class today? It comes down to one key trait: persistence. That's the belief that if you keep working at a problem long enough and don't give up, you can eventually solve it. Let me give you a real-world example. A researcher once filmed a woman named Renee working through a difficult math problem. He found that most people give up in just a few minutes, sometimes even less, when they get stuck. But Renee was different. Renee stayed with the same problem, thinking it through out loud, trying different approaches, and refusing to give up. She kept going for 22 straight minutes. She wasn't a math genius, but she had something just as powerful: a strong determination to keep working until it finally made sense. And then finally she gets it. Her reaction says everything: that small of relief and satisfaction. That's the reward, the feeling you get when you struggle with a problem and figure it out yourself. It's not about being given the answer. It's about earning it. For her, success wasn't about raw ability, but about attitude. Okay, so we've got our clues, the language advantage, and this deep cultural history of persistence. But there's one final piece of the puzzle, and honestly, this part is the most surprising. So every few years, students around the world take a major math test called TIMSS. But after the exam, they also have to complete a long survey, about 120 questions. It's repetitive and tiring, and many students don't even finish it. They just start skipping questions and leaving blanks. And this is where the researcher had a real breakthrough. Instead of looking at math scores, he ranked countries by something unexpected: how many students actually finished a long, boring survey after the test. When he compared that to the math rankings, the match was almost perfect. Countries with the most persistence on the survey were the same ones at the top in math. And who ends up at the top of both lists? Singapore, South Korea, Taiwan, Hong Kong, and Japan. It's not a coincidence. These are cultures shaped by a long legacy of intensive, disciplined work where persistence, effort, and meaningful labor have been deeply valued for generations. So, what's the big takeaway? Being good at math might have less to do with being a math person and more to do with culture, hard work, and persistence. And it makes you think, what else do we label as natural talent when it might actually come down to something simpler, like the willingness to stick with a problem for 22 minutes and not give up? Thank you again for joining us today, and we will see you again to explore more stories of the outliers.
If you'd like more personalized feedback, writing support, and discussion sessions, they're available with me or with our selected tutors. All the details are here.